Hello everyone. In this section, we are going to review the test we have learned. And then for some certain series, we want to see which method can be used easily for certain series. Okay, because sometimes we can use several tests for one series, but sometimes one works better than the others. So let's have a review. Okay, firstly, let's take a look. The first kind of series we learned is P-series. So whenever we see the P-series look like this, here include this harmonic, something like that. Okay, or even give by some other form, but after simplify, we can get a P form, P-series form. So the first case is converges for p greater than 1, and for p less equal to 1, that diverges. P-series, right? And the second one is we learned is geometric series. O n from 0 to infinity, a r to the n. They are the same thing, geometric series. And for geometric series, we know converges when r absolute value less equal to 1 and the sum equals a over 1 minus r, right? And when r absolute value greater than 1, that diverges and also equal to 1. Okay. Number 3, if the series has a similar form to the P-series and the geometric series, okay, has a form similar to the P-series and geometric series, then, and also be careful, this has to be positive, okay, positive term. And then we do what? We can do those tests. Comparison test. And similar to comparison test, we have a limit comparison test. Also, we have root test, ratio test. Okay, and also integral test. Integral test sometimes is not easy to evaluate, but when the integral is easily evaluated, we can use integral test. And based on those, between all those things, I like the ratio test the best. Okay, sometimes if they all work for the same series, maybe ratio test is best. And also, whenever we have factorial thing, like n factorial, we always use the root ratio test. And the root test, when our an, for example, we have some like power or even +1. So same thing. When there's some like n's power, we always like to use root test. Comparison test is something like, for example, 2 plus n squared. Right? This has a similar form to 1 over n squared. So in this case, we like to use comparison test or limit comparison test. Okay, similar to. Let's see. If our series has negative term, then we test this absolute values of an for converges absolutely. Absolutely, okay? Because when it's negative, we make this into positive, and then we can use all kinds of tests. And if this converges, we have theorem says if this converges absolutely, then an converges, right? So when we have negative terms, we like to do this way. Number 5, if you can see at a glance that, so can you guess if this is not 0, the limit of an is not 0, then we use the nth term divergence test. For example, if we have something like n plus 1, 2n minus 5, whatever like this, and by looking at this series, we know an goes to 1/2 is different from 0, then we can just say diverges, right? Number 6. Let's take a look. -1 to the n un, or sometimes negative to the n minus 1. So it just depends on the first term is positive, negative. So in this case, we call what? We call this alternating series, right? For alternating series, we have alternating test. Alternating test includes 3 parts: un positive, un decreasing, un goes to 0, something like that. And also for the alternating series, you can also use number 4. Same thing, okay? Because we can make alternating into positive too, and we can say it's absolutely convergent or not. Okay. Now let's take a look at the example. Example 1, the first one, n plus 5, 3n plus 1. So by looking at this one, we know an 3n plus 1. I know the limit goes to 1/3 is different from 0, so we can use the nth term divergence test. We say diverges, right? So our series diverges. Okay. Now let's take a look at the second one. This is the first example. Second, cube root of n cube plus 1 over 3n cube plus 4n squared plus 2. For this one, it has similar form. You know, we can ignore all those terms, and then we can compare, use the limit comparison test with cube root, the square root of n cube and the 3n cube. And after simplify, this is, let's see, oh, you can write down 3n to the 3/2. Actually, you can see this is similar to the p series. Is that right? With p greater than 1, actually converges. And we just need to find the limit. So here we use limit comparison test. Okay. You can test actually an over bn. I think the limit goes to 1, and then they both converge or diverge. And here, because bn converge, so an converge. So an series an converge. The third one, n e to the negative n squared, n from 1 to infinity. By looking at this series, you know, the result test is not very good, because when we have exponential function, which is e, usually when we have continuous function, you know, and also look at the function, the form of this function, it look like, if you think about this, we can do this by u sub, right? By u sub. So here we do integral by part, integral test. And when we do the integral, we need to do a little bit u sub. This is same as the quiz problem. So 1 to infinity. Firstly, we set up the integral, and we change this into improper integral. We change into the limit 1 to t x e to the negative x squared dx, and evaluate this by using u sub, right? And after we evaluate, this is negative 1/2 e minus e to the negative b squared. We skip the calculation, okay, here by u sub. And now let's take a look at the limit of this thing. So limit of e to the negative infinity goes to 0. So actually this term goes to 0. Define also is negative 1/2 times e. So converges, then our series converges. Number 4. Here we can use either alternating test or absolute convergence test. Okay, and if we use the absolute, if you test for this one, you can use comparison, limit comparison, or some other kind of test. But if we use the alternating, it's also work. Okay, alternating work. Test, because n cubed over n to the first plus 1 greater than 0, and it's decreasing, and it goes to 0 because denominator has higher power, right? Goes to 0. Next, 2k over n factorial. So we said whenever we have factorial thing, we like to do ratio test, right? Ratio. And here we can an plus 1 over an, which is 2. Actually this is k, but same thing, you know, before we usually use n, k plus 1 over k plus 1 factorial times k factorial over 2k, and simplify. 2 cancel out, and this cancel with that, k plus 1 left, and then we cancel the k plus 1, k plus 1, so this is 1 over k. K goes to infinity, whole thing goes to 0, less than 1. Then by ratio test, this series converges. Okay, so whenever we have factorial, try ratio test. Number 6. 2 plus 3 to the n. Can you see what the test we want can work best for this one? You can think about this, right? What's the series is this one? Geometric series with the ratio r equals 1/3, less than 1, and converges. And now let's see, so we can use comparison test, right? So it's 1 over 2 plus 3 to the n, compare with this term. Denominator is greater than 1, whole thing less than. that smaller than converges. So our series converges. Okay, so that's all the tests with we can use here, but there's no unique test for some series. You can try all different way, but just sometimes certain method test can work better and faster. But we have to do more exercise and then get the experience, and when you see the problem, you will know directly which method you are going to use. Okay, that is the strategy for testing series, and we can stop here. You can try all the homework problems.